Now, let's look at our first method of approximating area, the left-endpoint approximation. In this method, we use the left side of each interval to determine the height of each rectangle. Let's look at the graph on the right. We have a total of 4 rectangles. To estimate the area under this curve, we find the area of each rectangle and we add them up. The area of the first rectangle is width times length. The area of the second rectangle is width times length. The area of the third rectangle is width times length. The area of the fourth rectangle is width times length. So the width are the same, which is delta x. Now, how do we find the length of each rectangle? In each rectangle, we have the left and the right endpoint. For the first rectangle, this is the left endpoint. This is the right endpoint. For the second rectangle, this is the left endpoint. This is the right endpoint. For the third rectangle, this is the left endpoint. This is the right endpoint. And for the fourth rectangle, this is the left endpoint. And this is the right endpoint. Now, in this method, the length of the rectangles come from the left endpoints. So for each rectangle, we start at the left endpoint of the interval, go straight up until we hit the curve, and that gives us the height of the rectangle. So the height of the first rectangle is f of x0. For the second rectangle, we start with the left endpoint and go straight up until we hit the graph. This is the length of the second rectangle, which is f of x1. For the third rectangle, we start with the left endpoint, go straight up to the curve. This is the length of the third rectangle, which is f of x2. For the fourth rectangle, we start at the left endpoint, go straight up to the curve. This is the length of the last rectangle, which is f of x3. So, the area for the first rectangle is delta x times f of x0. The area of the second rectangle is delta x times f of x1. The area of the third rectangle is delta x times f of x2. And the area of the fourth rectangle is delta x times f of x3. And to approximate the area under this curve, we add the area of these 4 rectangles up. Now let's connect this to the formula. Ln represents the left endpoint approximation equals the sum from I equals 1 to n of f of x sub I minus 1 times delta x. Delta x is the width of each rectangle, and f of x sub I minus 1 is the length of each rectangle. Now, let's apply this to an example. We're given f of x equals x squared, the interval from 0 to 2, n equals 4. First, let's find delta x. Delta x equals b minus a over n. B is 2, A is 0, and N is 4. So I have 2 minus 0 over 4, which is 0.5. Step 2, find the x values. So I have the interval from 0 to 2, and I want to split this into 4 equal parts. This is x0, x1, x2, x3, and x4, where x0 is a, which is 0, x4 is b, which is 2. To find the other x values, I start with x0, and I keep adding delta x. So x0 is 0. To find x1, I take 0 plus 0.5, so x1 is 0.5. To find x2, I take x1 plus 0.5, so 0.5 plus 0.5 is 1. To find x3, I take 1 plus 0.5, which is 1.5. And x4 is 2. In this example, we want to use the left endpoints. So the left endpoints are x0, x1, x2, and x3. Next, set up the sum. So the formula is ln equals the sum from I equals 1 to n of f of x sub I minus 1 times delta x. In this case, delta x is 0.5 and n is 4. So I have L of 4 equals the sum from I equals 1 to 4 times f of x sub I minus 1 times 0.5. And 0.5 is a constant, so we are going to put that outside of the sum. So we have 0.5 times the sum of f of x sub I minus 1. Now let's expand this. When I equals 1, 1 minus 1 is 0, so I have f of x 0. When I equals 2, 2 minus 1 is 1, so I have f of x 1. When I is 3, 3 minus 1 is 2, so I have f of x 2. When I is 4, 4 minus 1 is 3, so I have f of x 3. x0 equals 0, x1 equals 0.5, x2 equals 1, x3 equals 1.5. So we substitute those values in. And f of x is x squared. So f of 0 is 0 squared. F of 0.5 is 0.5 squared. F of 1 is 1 squared. And f of 1.5 is 1.5 squared. We're going to add them up and multiply by 0.5. We get 1.75. Now let's look at the graph. All rectangles use the left side. They stay below the curve, so the total area is slightly smaller than the actual area. The left endpoint approximation gives an underestimate when the function is increasing. Next, we'll look at the right endpoint method and see how it compares.